In this session, I'll be dealing with the fifth module of network theory, two-port network parameters. This is a two-port network. It has two pairs of terminals, one at the input known as the input port and another at the output known as the output port. There are four variables here: V1, which is the input voltage, V2, which is the output voltage, I1, which is the input current, and I2, which is the output current. These are the four variables: V1, V2, I1, and I2. These four variables can be used to define the various two-port parameters. Any two of these variables can be expressed in terms of the other two variables. Okay. These are the different parameters we have to study in this chapter, the different two-port network parameters. Open circuit impedance parameter or Z parameter, short circuit admittance parameter or Y parameter, ABCD parameter or transmission parameter, and A', B', C', D' parameter or inverse transmission parameter, H parameter or hybrid parameter, G parameter or inverse hybrid parameter. Here, coming to Z parameter, it is the open circuit impedance parameter. It is expressed. V1 and V2 are expressed in terms of I1 and I2. Z11, Z12, Z21 and Z22 are the different open circuit impedance parameters or Z parameters. Likewise, we have Y parameter. It is I1 and I2 are expressed in terms of V1 and V2. We can see the equations here. Here Y11, Y12, Y21 and Y22 are the different Y parameters. Now coming to transmission parameter or ABCD parameter, these are expressed in A, B, C and D. Here V1 and I1 are expressed in terms of V2 and I2. And here also we have a negative sign. Coming to inverse transmission parameter, A', B', C', D' parameter. Here V2 and I2 are expressed in terms of V1 and I1. And the different inverse transmission parameters are A', B', C' and D'. And coming to hybrid parameters, V1 and I2 are expressed in terms of I1 and V2. And the different H hybrid parameters or H parameters are H11, H12, H21 and H22. Coming to inverse hybrid parameter, I1 and V2 are expressed in terms of V1 and I2. See, I1 and V2 are expressed in terms of V1 and I2. The different G parameters are G11, G12, G21 and G22. Now we can see each of these in detail. Open circuit impedance parameter or Z parameter. Here we have, I've already said, V1 and V2 are expressed as a function of, expressed in terms of, or is expressed as a function of I1 and I2. So we can write the general equation as this, as we have already said. We can write it in matrix form. V1, V2 is equal to Z11, Z12, Z21, Z22 matrix into I1, I2 matrix. We can write it generally as V matrix is equal to matrix of Z into matrix of I. Now we can see each of these parameters individually. For that, we have to consider two cases. The case when output port is open circuited and the second case when input port is open circuited. Case 1, when output port is open circuited. See, in this network, in this two-port network, when output port is open circuited, the meaning is that the current I2 is set to be 0. See, from these two equations of these are the Z parameter equations, and in this equation, when I2 is put as 0, we can get Z11 and Z21. Let's see that. Z11 is equal to V1 by I1 when I2 is equal to 0. We can write it from this equation. And also Z21 is equal to V2 by I1 when I2 is equal to 0. That is from the second equation. Z11 is the driving point impedance with output port open circuited. We have learned what driving point function is, and it is also called open circuit input impedance. See, V1 by I1, that is the input impedance. V by I will give you the impedance, and also it is at the input, and we have obtained it by open circuiting the output. That is why it is called open circuit input impedance. And Z21 is called the transfer impedance with output port open circuited. Okay, transfer impedance. We have learned what transfer impedance is in the last module, in the fourth module. That is V2 by I1. Okay, it's also called open circuit forward transfer impedance. Next case, when input port is open circuited. Input port is open circuited means that is the input current is equal to 0. So here, let me write the equation once more. Here, on making the I1 0, this term will go to 0. So we can find Z12 and Z22 by open circuiting the input terminal. So we can write Z12 is equal to V1 by I2 at I1 is equal to 0, and Z22 is equal to V2 by I2 at I1 is equal to 0. Here Z12 is known as the transfer impedance with input port open circuited. It is V1 by I2. And also it is called open circuit reverse transfer impedance. It is a transfer impedance, but it is reverse, V1 by 2. Okay. Earlier it was Z21 was V2 by 1. Therefore it was forward transfer impedance. Here we have Z12 is equal to V1 by I2, 1 by V1 by I2. Therefore, it is called reverse transfer impedance. It is the transfer impedance with input port open circuited. Also, it is called open circuit reverse transfer impedance. Now, we will go to Z22. Z22 is V2 by I2. It is a driving point impedance function with the input port open circuited. And also it is called open circuit output impedance. Output impedance because V2 by I2. It is a second terminal impedance. That is the output terminal impedance. All the Z parameters Z11, Z12, Z21 and Z22 are called open circuit impedance parameters because these are measured with either the input or output port open circuited. That is why it is called open circuit impedance parameter. All these parameters are measured by keeping either the input terminal open circuited or the output terminal open circuited. That is why they are called open circuit impedance parameters. This is the equivalent circuit of the two-port network in terms of Z parameter. So now we are going to see the equivalent circuit of the two-port network in terms of Z parameter. So we can understand this circuit better by writing the two equations of Z parameter. V1 is equal to Z11 I1. See, Z11 I1 plus Z12 I2. Z12 I2 means it is a dependent source. That is I2 is the current in this branch, and here we have a voltage which is dependent on the current in this branch. Okay, that is why we have a dependent source over here. So we can write the equation V1 is equal to I1 into Z11 plus Z12 into I2. Okay, that is the equation and this is the equivalent. And coming to V2, also one more thing, it is a sum of two voltages. So we have represented this as a series of two voltages. Sum of two voltages, we have put it in series. Okay, if it was the sum of two currents, here we have voltage, that is why it is in series. If we had a current variable here, the sum of two currents would have been, we could have drawn these two in parallel. Okay, since it is a voltage, we have considered these two parameters in series. Now coming to the right hand side, V2 is equal to I2 into Z22 plus Z21 into I1. Okay, this is the equivalent circuit of the two-port network in terms of Z parameter. Next is condition for reciprocity. Reciprocity theorem states that the ratio of excitation to response is same if the excitation and response are interchanged. Okay, here we have in this two-port network, these are the two cases. That is, here when we apply a voltage Vs, we get a current I2 dash. The ratio of Vs and I2 dash will be same as when their positions are interchanged. Okay, that is, when we apply a voltage at this terminal, that is at the output terminal, we will get a current I dash at the I1 dash at the input terminal. Okay, so the ratio of Vs by I1 dash will be same as Vs by I2 dash, and we have to prove it. First, we can see the case when the voltage is applied at the input terminal and the current is obtained at the output terminal. So here V1 is equal to Vs and the V2 is equal to 0, and here I2 is equal to minus I2 dash. Okay, so we can write the equation, the first equation of the Z parameter, that is V2 is equal to Z11 I1 plus Z12 I2. I2 is minus I2 dash. So we can write minus I2 dash. So we can write this as Z11 I1 minus Z12 I2 dash. Okay, this is the first equation. The second equation we can write it as V2 is equal to, here V2 is equal to, sorry, this is V1. So V1, and therefore we have to write it as Vs. Here it is Vs. So the second equation we can write it as V2 is equal to, this is the actual second equation. So we can write it as 0 is equal to Z21 I1 minus Z22 I2 dash. And this equation was V1 is equal to Z11 I1 plus Z12 I2. So instead of V1 we have written as Vs, because at the input terminal we have got the voltage Vs. Z11 I1 and Z12 I2 dash is the output, that is the response at the output. So we have got the two equations. So from this we have to find the ratio of Vs by I2 dash, the ratio of excitation to response. We have to find Vs by I2 dash. So for that we have got an equation with Vs and I2 dash, and here we have got an I1, and we have to replace this I1 with some term of I2 dash, and say from this equation we can get I1 in terms of I2 dash. Okay, from this equation we will get I1 is equal to Z22 into I2 dash by Z21, that is I1. We can put this I1 in this equation. This is the equation with I1 substituted in equation number 1. Now we can get Vs by I2 dash from this equation. This is the equation. I'll explain the rest in the next lecture.